Julio.
Okay, any announcements?
There's a Christmas dinner tonight?
There is a Christmas dinner tonight.
There is, yes.
Please see the local Zulip channel for details if you are local.
So we have been asked to use one slide for tomorrow. So I will do that and I'll put it on Zulip for the comments and then once you put it.
Slide for what?
For the home office visit.
Oh, is that tomorrow?
Okay.
Oh. Okay, yeah, nothing else happening tomorrow. Cool. Shall we start? Cool. I will not really be monitoring the chat, so if anyone would ding, let me know. Cool, right. So you were promised to talk about Horde triples yesterday, so we're going to do something similar today, looking at a language called Dafny, which is a design by contract. Sorry, it's a programming language which is designed by contract built into the language design itself. I'm going to look at the formal verification of imperative programs in this language. I thought it was a nice change to look at Dafny compared to what we've seen previously, because we're mostly interested in the functional programming world and dependent type theory, and that's quite, I really like that world. People don't necessarily have that in their background. What Dafny gives us is an ability to learn how to reason about code using contracts, but in the imperative world. And so when I said it's a nice bridging language, I'm talking about, I try and use it in 886 to provide students with a way to be familiar with coding, but also to begin their journey in looking at programming. So the goals of today are, I'm going to show you the basics of Dafny, nothing too intense, because I don't do it really for research, but I just show you how you can do design by contract, and there might be some anecdotal comparison with how we do things in languages like Idris and Agda. If there's any questions, please do ask and raise your hand if you can. Cool, right. So what I want to begin with is looking at basic Dafny to show you the syntax. This is not necessarily it being verified, but just what we can do. So we're used to pure functions, but in Dafny we have methods. Okay, I prefer KNR, and so a method is something that is impure, so I can just do something scary like this, and you see some code completion happening because Dafny has a nice bit of, not really nice bit of interactive, but it's it helps you write your code. So you can start write print and go hello world, answer Sean's message, and then you need a semicolon because we're doing something, right? And this is about it. And what you may not have seen is as I was writing this, there was a little bit of a error bar here on the left. Now this is why we have two things, and I'm just going to move things around a little. And if I remember correctly, I have slide check, show all errors, and that's the wrong thing. Of course, I love my code. I'll do that here, and flat check errors. Cool. And what I'm going to keep this other buffer up here, which is listed errors, just to show you what the compiler is doing in the background. So if you're not familiar with the design by contract, I will get onto that in a bit. Cool. So we have hello world. What else can we do? We can have binders, so we can bind variables. So we have x's here, and oh, I've made a mistake, and I can do 1, 2, 4. Right, I put this. It's giving me error messages. We can slice them, so we can get the head of the list. Oh, sorry, I've got a thing coming up that says it's refreshing my app because, you know, we have full control over our machines. X equals x is 0. We can take slices. So this is basically binding, but we have this thing called for loop. So I can do for I equals 0 to the length of x's, and I can do print x's I. Okay. And say, why does it not like this? Cool, it does. Sometimes a good time. Okay, so this is a very simple imperative program. You can sort of see I've created some list known as sequences. I can slice them, as in I can index them. So here x is the head of the list. I can do var t's to get the tail of the list by doing a little bit of a slice, and everything is hunky-dory. Okay, so this might be new to you because you have things like iteration and impure functions, but it's just to show you that it is a working language. I would show bits about the compilation, but I can say that later. The only thing to notice here with Dafny is, like Idris, you can retarget different backends. So you can generate C# for the .NET platform, you can generate Python, Go, there's an experimental backend for Rust, Java and not JavaScript. So this is one of the interesting things about like with the Idris language, is you can verify it in a nice language, but then generate code for your target environment. And this is quite cool. And if you're unfamiliar with a bit of Dafny, is it was developed by, or is developed at Amazon and Microsoft, and the Cedar policy language was initially developed in Dafny before being translated into Lean. So it has got real world usage and real world impact. So I've done this, I'm going to go forward on, because I want to look at more verifying and proving. So this is the language, and I like to have things at the top. Cool.
So is print like polymorphic, or is it
Yeah.
overloaded?
I would argue just say polymorphic, because you can also, just to show a bit more about print, we can do this, but we can also say 1, 2, 3, and do fancy things like this, which is not necessarily ideal, but it's what you can do in the language.
And what does that mean?
This means it will cast anything that's not a string into a string. Okay?
Can you print a function?
Sorry?
Can you print a function?
We'll get onto that.
But is that doing traverse basically?
To be fair, I just don't know. Okay? So let's move on. So one thing I want to talk about is method prototypes. So I want to show you a prototype for the unsafe doubling of sequences. So again, we have a method, and there's a key thing here that from the C# family, we capitalize our method names. Okay, I know some people squinted at that, but that's what happens. So X's, and we're calling them sequences, and it's T. So if we want to make a function polymorphic, we actually have to introduce the type variable. You'll see this if you use languages like Python and their type hints, you do this as well. And we want to, this is where it gets a bit more weird, we have to say we return, or sorry, returns X, Y's sequence T, because we are in a contract world, and so we might want to refer to the name of a result, and so we actually have to give an explicit name. We actually have to do this for every single method. This is not ideal, because I end up, when I'm coding in Dafny, to say, well, not something meaningful, I just go, you know, res or result. We'll see examples of why we need to name things in a little bit, but this is just to show you that. Because one of the nice things about this was, it's a little bit freaky. So if we want to double sequences, we can say, I don't know, y equals nil. Okay? Because we have these names for the result can exist in the method body. It's a really freaky thing, right? So we're in an imperative programming language, so we can, but we've got a name, y's, and we actually just, and these are called result binders, and just bind the result of the method to this name. I thought it was a bit freaky, but then here we've written something double, but we want to do something a little bit better, but we'll work our way up with this on how we can make doubling of sequences safe.
So this with no modification will return this empty list.
Yes.
Very
So this is the thing, so one of the things to realize with Dafny, some nice languages, the notion of a verification aware. So I can write unsafe code in here, but if there's stuff I do care about, we can start providing more properties to say what does it mean for this code to be correct. And this is one thing I wanted to sort of show. This is, and in Dafny's contract way of doing things. Anything else I wanted to say here? Oh yeah, functions, right? So one thing that's nice about Dafny is that you can, if you like functional programming, you can start writing functions, right? You can write a function, and you can do it lowercase if you want to, or you can do it uppercase, but it can look pretty much the same signature T. But what you can do instead is you can just say seek T, and it will